Welcome back to our little mini series of videos on basic chart work using just very basic chart work tools. Just to resume, so far we know how to measure the position coordinate of any point on a nautical chart of Mercator projection. And then we went about the latitude scale, how to measure the distance of between 2 points anywhere along this chart, which we can also use the same technique to measure each leg of a plotted course to determine the total distance of our voyage between point A and point B. What I'd like to do now is demonstrate how to use a parallel ruler. What we're going to do with that is we're going to measure the angular measurement of our course over the horizon as it would be referenced to true north. As we know already, Mercator charts, the meridian lines on it are referenced to true north and south. They are aligned with the axis of rotation of our planet. And so, simply put, any line traced on this piece of paper would cross any meridian at the same angle. It is simply an angular measurement reference to true north, where we would start to count at 0. So true north would be 0, 0, 0. If we would be running a northerly course, our course heading or course made good over the earth would be 0, 0, 0. So I'm going to be using the same course line I've utilized in a previous video to measure distances. If you guys remember, this was 4.8 nautical miles long. What I'm going to do right now is simply measure the angular measurement between that line and any meridian of longitude, and I'm going to transpose that over to our true compass rose, which there are several of them printed on a Mercator chart. I'll show you and demonstrate how to use a parallel ruler, and I'm going to demonstrate 2 different ways of using it. The number one, which is not the most advantageous, simply because of the logistics of doing this once you're on a vessel that may be at sea. You'll see the challenges that this may pose, but let's start with the basics. So I have my line here, my course line. We are headed in this direction as demonstrated by the arrow over here. And all I do is line up the top edge of my parallel ruler right up against it. I make sure it's the exact same angle, and that's pretty simple. I have nearby on the paper chart a compass rose, and the outer ring, the outermost ring of the compass rose is referenced to true north, and the angular measurement from true north all the way around, so 360 degrees, is noted on the outer edge. So I just use my parallel ruler and I make sure it's not moving by pressing down on each half of it, and I use the little knobs so that I can walk the parallel ruler across the chart, being extremely careful to not make it wiggle. And then I just walk the thing, and it's kind of finicky until you have an edge basically going straight through the very middle of the compass rose. That is crucial, is that the edge of the ruler, it doesn't matter which edge we are using, is going through the middle of the compass rose. And I put a blue line here just so you can see it. Where that line comes out at the outer edge, keeping in mind we're proceeding in this direction along our course line, that is our course. And if I read off this course, it is 062. I would simply then go back to my course line and note 062 with the letter T next to it, meaning that that would be a true course. It would be the course made good to follow on the water to go along with this course line in reference to true north. Now, method number 2, which is a lot more effective and does not require you to walk this parallel ruler across the chart to a nearby compass rose, running the risk of wiggling along the way and coming out with an inaccurate measurement. If you have a good parallel ruler, a proper nautical parallel ruler would be equipped with a printed or etched into the resin a protractor, which is simply a tool that measures angles, angular measurements. And you'll notice that at the top edge are angles, and at the bottom edge are cardinal points of the compass as they relate to each angle. So on here, we got 90 degrees, and the reciprocal, so the opposite would be 270 degrees. And then perpendicular to that would be south. And we have the letter S over here for the southern cardinal point of the compass. It doesn't really matter to wrap your mind around this right now. All you need to know for the technique itself, for simplicity's sake, is that once you have your parallel ruler back onto your line, all I do is slide the letter S to any meridian of longitude. Now remember that this angular measurement will cross any meridians of longitude on this paper chart at the exact same angle. So 45 degrees relative to true north is 45 degrees all the way across the chart. So as such, it does not matter which meridian line you utilize. But for practicality and for not moving, the sake of not moving this parallel ruler too much, you're going to use the one that's the closest. So just slide the parallel ruler along my course line until the letter S intersects the nearest meridian. And where the meridian comes out is my course. And if you look over here, you'll see that the meridian line comes out at 0.62, the same measurement that was over here. Now, one of the things to pay attention to is the fact that the protractor will provide you with the angle going one direction, and directly underneath will be the read off of the angle going the opposite direction, known as the reciprocal course. So it is important to note which direction of travel you're proceeding along that line to make sure that you read off the right angular measurement. Again, I've slid the parallel ruler with the letter S just intersecting this meridian, and where this meridian comes out of the top edge of the parallel ruler, where it is graduated in angles, I'm reading off 20, 30, 40, 50, so the numbers grow in that direction. And where the meridian comes out is 060, 061, 062. And I know that it is the right number because I'm proceeding in a northeasterly direction, so roughly 62 degrees relative to true north, expressed properly for a course heading as 062 without using the word degrees. Why? Well, because this is not a bearing, this is a course. So I hope that helps. Two different methods to use a parallel ruler. Stay tuned for part 4. Thank you.